Yeah, there's a yeah. First one came up that.
Hey, James, you had a question with one. So you said before, let me see, I got all my stuff.
Y equals 38 over x minus 9. It was just something random like that. And then for the answers, I came up there, wanted me to give like negative infinity, positive 9.
Oh, yeah, because I ended up leaving these, I think, because they sneak in there. I think I probably didn't even talk about it, did I? Yeah. So let me clarify. This is in 4.5, okay, was where this shows up at. This bottom part, this denominator, if you remember when we talked about fractions before, the denominator can never, ever, ever, ever equal 0. Because as soon as this equals 0, what happens? It becomes undefined. So I can never have 0 there. So you take whatever that denominator is and make sure that you set it equal to 0 and you solve for x. But what this means is that x can never equal 9. So it can never end up being, get this thing out of the bottom here. So it can never equal 9. And so since it can never equal 9, we need a hole in our inequality, or in our interval notation. Because what this means on a number line is here's 9 and 10 and 11. I can have everything going this way, and I can have everything going this way, but I can never have 9. So when I do my interval notation, it's a negative infinity to 9, but I can't include it, unioned with from 9 to a positive infinity. And so that would be your solution that you'd have in there. Okay? So I apologize that I left that piece off there. Yes? 4.4, your negatives and positives. Do you have an example? What's your example? Because 9.4 was broken into 2 parts, and it was the parallel part, parallels and perpendiculars, because that's what we did last time.
Yeah. Like stuff like this, I would always like
Okay, so y plus 3 equals a negative 3/4 x plus 3. Okay, and you probably had plus 12?
Yeah.
And probably what we had to do with this one is you had to come up with a point, right? I think it's probably what it asked you to do.
Yeah.
This was inside of parentheses, though, wasn't it? The x plus 12?
Yeah.
Okay. And what this is looking at is your formula. Your formula is y minus y1 is equal to the slope times x minus x1. Okay? It's always a subtraction in here. So because this is a plus in here, I would have to reverse it. So really I have y minus a negative 3 because a subtraction and a negative makes it a plus. And negative 3/4, and this one the same thing. So my point in here is really negative 3 and a negative 12. Okay, but in this case, you'd have to change those. So you wanted to make sure you flipped them and changed them.
Like right here, I have, I wrote it down because
Okay.
pattern between negative and positive. So I wrote down 4x minus 7y equals 5. And the slope for that would always come out to positive, which I would always think that would be a negative.
Okay.
Would be 4 over
Yep.
negative 7.
Yep, but we can fix this. So let me show you, because when you move your 4 over, it's negative. Okay, so negative 7y, this stays with that 7, equals negative 4 plus 4x plus 5. Okay, so then what we need to do is, because this is a negative 7, when I divide each piece by a negative 7, I have to look at mathematically what's taking place here. I've got a negative divided by a negative, which is going to make it a positive. Okay? Yep, that's the part you got to be careful with, is you got to make sure in here that you take these two and you got a negative divided by a negative makes it a positive. Here, you've got a positive 5 divided by a negative 7, which is going to make it a negative 5/7. Yes. That's a going back to chapter 2, I think, when we were doing negatives and dividing by negatives and doing that whole thing. It's probably something you just accidentally forgot, but you got to be careful. So this negative divided by a negative makes it a positive. That's how they're getting that. Okay, so that should help you. That's the cure-all of all those. So it's a sign thing and making sure you get your signs in the right spot. Okay, others? Anything else that we need to go over? That was 4.4b, and 4.5 was where we had the stuff in there. Okay, so you want to watch those. Yes? With the,
I don't really have anything to reference it.
which section, do you remember?
It's the last one.
Section 4.4 or 4.5, okay.
Yeah.
Was it a graph?
Yeah, it was a graph from.
What did the graph look like? Was it a circle? Was it a...
It was like.
Oh, a V?
Like this,
Okay,
but,
yep. So it was doing one of these things. It was a V doing this stuff?
Yeah.
Like that?
Yes.
Like that one? Okay. And you're looking for domains and ranges?
Yes.
Okay.
It's more the range.
The range? Okay. Range is Y's. And like I told you the other day, these keep going on and on and on, okay? So when I'm walking and it's just like taking it and walking it, you need to look at it that way. Since you're looking at ranges, you're walking along Y here, and notice every time I go across on Y here, I hit something. Do you see that? Okay, so I've hit everything from down here that I can possibly hit. So that's where negative infinity is at. But as I get up here, I hit right there, but then I get up here and the field's wide open. I see absolutely nothing else, okay? There's nothing from here on up. So it stops at 0, okay? So because it stops at 0, that means my range is going to be from a negative infinity, which I don't know where it ends, to 0, where I know it ends. Does that help you out?
Yeah, it just seems weird. It seems like it's written backwards.
It is. It kind of is, but you got to keep in track of your number line or your y-axis and where the numbers are. You start at 0 and we go negative down this way, and we go positive in that direction. So really, I have to start with a negative infinity. Or, of course, you can't shift your graphs on Hawks, but if I turned it negative infinity to positive over here, then you kind of get the idea that it's running correct. Okay? So you got to tip yourself, no, and look at it sideways so that you get your, yeah, flip your computer on the side, yeah, so that you see what happens. Uh-huh.
I had one. I think it was like y equals 29 over x minus 4 or something like that.
Yeah, we just had one of those, and I apologized earlier to everybody because I didn't put one of those in my notes. But what it means is this can never equal 0.
Okay.
So you set it equal to 0, and you solve for x, and you find x can never, ever equal 4. So you leave that 4 blank in your interval notations. And you do that to leave it blank with parentheses, because that means I can never have 4. And you union it with 4 to a positive infinity. Okay? Yeah. Yep. And that, again, wasn't in there. So so hopefully the video I sent to you helped you out, some of you. Because, again, I had so many of you not here so last time. But anyway, that's what happens with this piece. Okay? So any other ones? Anything else? Good review of all those sections because, again, we pulled up our stuff that we need to do. So to finish this one up here, I need domain. So since these go on indefinitely, every time I walk along X, I'm going to hit somebody all the way down. Okay? So there's going to be always something in there, so my domain on this one is going to be from a negative infinity to a positive infinity because it doesn't stop. Okay, so again, domains X's, range is Y's. So if you always take that, and again, just take your cursor that's in your program and just kind of go back and forth and see, do I touch something? If I'm touching something, then that means I've got some stuff there. Okay, if I get up here and I'm going across here and I see absolutely nothing up here, that means that I don't have stuff there. So you want to make sure that you're careful with that part. Any other ones in that piece? Okay, no? We're good, you think? Okay. Last section. So that means Monday is your test over Chapter 4. And so we're going to finish up the graphing stuff today with Chapter 4. And we have one section left, and that is 4.6. And 4.6 is graphing inequalities. What you learn here today is something we're going to use in intermediate algebra. We ended up graphing in Chapter 8 2 of these on top of each other, but in here we're only going to graph one single line and see what happens with it. So with inequalities, what you're looking at is something that is y is greater than x plus 4. You might see y is less than or equal to 2/3 x minus 1. And so with our inequalities, that means this section that's in between here. So all of our inequalities are less than, or greater or less, greater than, and less than. Or we have greater than or equal to, or less than or equal to, as our inequalities that are in here. Now in Hawks, it's going to say, based on these lines, we're going to graph lines. So what do we have within this equation? Well, we have our y-intercept, right? That's our starting gate when we run our race. So we start at 4, up 4. Then our slope, and our slope's what's in front of x. And in this case, our slope is 1/1. And so we got this information that we have, and we graph our line. So we start at 4. We graph that whole thing. But there's a couple things we need to keep in mind, is because with inequalities, if I have no equals, so there is no equals, whoops, the line cannot be included. We can't include it. So in this case, I can't include the line. So what we're going to do to show that the line is not included is we're going to make a dashed line. So a dashed line is going to go like so. So we know that we're going to have a dashed line whenever I have no equals involved. If you have an equals, the line can be included. So it includes the line. So because it includes a line, we're going to have a solid line. So we're going to have a solid line. So if I graph this one, the line would end up being solid. Okay? So we have two different things that are going on here. So we have that part. So this one's dashed, this one's solid. You get that idea? To look at just this piece. You don't have to look at anything else in the equation to figure out whether your line's solid or dashed. Just look at your inequality. So your inequality will tell you that. And on Hawks, and we'll go to Hawks in a minute here after we get an idea of what we're doing with these, and where I'm going to show you that it pops that in there and you have to select whether it's dashed or solid. And so we'll go through and work that part out. But the thing about inequalities is that when we had equals, the equals only pertain to the line. So equals only pertains to the line, and only the points on the line were answers. So if I had y equals x plus 4, and I go through and I graph that, it says I'm going to be up at 4. Slope tells me to rise 1 and run 1. And so my answer to this solution is only that line, okay? And that's what we've had so far. We've only had just lines. We haven't had anything else with lines. It's just been this straight line that happens to be in there. With inequalities, though, we have a whole range of different points. We have a whole bunch of different things that can happen that can be solutions to it, because we're not limited just to that line. We're limited to either side of the line. So if I take the same equation and I say, what did I have? Y is greater than x plus 4. And I go through, and I'm going to stick this on graph paper this time so that we can see what's taking place with it. So if I graph this, what I now have is the graph of the line, and we said it was going to be dashed because we knew that we had no equals in here. So that means I'm still going to go up 4. Whoops, 4. So that's 1 point. 0, 4 is a point that is on that line. So I can use that. If it asks me for a point, I can use that point. Then my slope says to rise 1 and run 1. But because I know the line is dashed, on paper, I would have to make sure I showed a dashed line because I don't want to include that line in my answer. So it's not a piece of that. So now what happens to this whole thing is we end up with two sides of the line. One side of the line is over here. The other side of the line is over here. And so we need to decide what side makes this thing work. What side is a true solution to this? What side is gonna be the one I can pick points out of? And so if I look at that, I can pick a test point. My usual test point that I pick is if it's 0, 0, the origin, so a test point. So if 0, 0 is not on my line, I can use it as a test point. And a test point meaning that whatever I have for an equation, I can go back and plug 0, 0 into it and see if it makes it a true solution. So 0 is greater than 0 plus 4. So 0 replaced y and 0 replaced x. Is 0 greater than 4? What will all of you say? No, no way, right? This is false. So I would not pick the purple side, okay? So don't pick the purple side. So this side is not the right side to shade. And in Hawks, they will label these as A and B. So you would pick side A to be your shaded answer, okay? Because every point over here is going to make it work. So if I picked the point -3, +3, so if I pick -3, +3, will it make it work? So I'm going to put 3 in for y, a -3 in for x, plus 4, and notice 3 is bigger than 1, so it worked. Okay, so now this point is true, so I want to shade that whole side. Now, am I only limited to negative 3, 3? No, I've got all of this whole side. Any point in that whole region is going to make my statement true. Okay, that makes sense? Hopefully. Okay, now in Hawks it's going to say, what's another point? They'll ask you for 1 point, and they'll say, what's another point? Well, if you do your slope intercept in here, your intercept is here, you rise 1 and run 1, you've got a second point. That second point is at 1, 5. So I have an extra point in there. So when it asks for 2 points on this line, if you do your slope intercept stuff, you're going to have 2 points. You'll have the intercept, and you will have an additional point, okay, for that one. So let's go look at the other equation I had put in here, which was y is less than or equal to 2/3 x minus 1, I think. Yep. So what's it going to look like? So, is my line solid or is my line dashed? Solid. Easiest piece of all, because it's got an equal, so it's solid. So then, if I get my graph paper and I graph this thing on here, my slope, it's just gonna, or my intercept, which is gonna be one of my points, is 0, negative 1. So 0, negative 1. Slope says up to and over 3. Hopefully you guys are all good at that, right? Are we all good at that? Up 3 and over 2, or up 2 and over 3. We said it was solid, so I gotta draw a solid line. We got solid in there. And because it's solid, we know that that's going to break our graph into 2 pieces. Okay, so if I need a second point for Hawks, because it's going to ask me for a second point, where's my second point? Right here. So it's over 3 up 1. So my second point is 3, 1. All right, I don't have to put in and come up with another point. It's right there. It's part of this whole thing, okay? So it's what I happen to have there. So I want to make sure that I get that piece in place, okay? So that it is in that location. Now I got to decide what side's shaded, because I'm no longer just with a line. So test point, 0, 0. Is it true or false? Does it make my statement true? 0 for y is less than or equal to 2/3 times 0 minus 1. Is 0 less than or equal to a negative 1? Is that true or false? Yep. Is that true or false? 0 is less than a negative 1. False, yep. So far our stuff has all come out false. It doesn't always happen that way. So this is false. So where would I want to shade? Well, I would want to shade below the line. So again, what Hawks will say is you have side A and you have side B. So you need to pick which one gets, whoops, side B, which one gets shaded. So we would pick side B. Mm-hmm. 3 and 1? Oh, how I got that? Okay. My slope is 2, 3, or 2 over 3. So my intercept is at negative 1. Okay. So if I use my slope, it says rise 2 and run 3. And then all I do is look at where that location is. That location is at 1, 2, 3, up 1. Okay. I got to put my X first, and then my Y goes in second. So you've got that 2 combination going in there, okay? So you've got your pieces coming together for that, okay? So you want to make sure that you get your stuff in place. Does that make sense?
Yes.
Okay. All right. Let's look at another one. What if I had 2x plus 3y is greater than or equal to 9? Well, if I have this one, I can certainly pick out whether my line is solid or dashed. Which is it? Solid. Easy piece. So my line's solid. We know that. But I can't graph this the way it looks, right? Because I need to make sure that I get stuff on the right side here. So I'm going to minus 2x. So now I have 3y is greater than or equal to a negative 2x plus 9. And then from here, I need to get y by itself. So divide each piece by 3. So negative 2/3 x. 9 divided by 3 is 3. So now I have something I can graph. All right? And we did this. That was, 9 or 4.4. Was it 4? No, 4.3 I think we did in getting things solved for y and graphing with slopes and intercepts. Okay, so now we got to graph it. So let's see here what we end up with. Now Hawks will ask you sometimes for slope-intercept form, and it will graph from there, or it's going to ask you for points, so we can find some points in here. So we've got 1 point. 0, 3, because that's my y-intercept. My slope says I got to do what? Down 2 and over 3. And where's that point located at? And that is another point that I have. So it's 3, 1, just like the last one I had. And we said our line was solid, so we draw a solid line. And then, what side gets shaded? Do I shade side A, or do I shade side B? So, test point, 0, 0. Plug it into the original one. So 2 times 0 plus 3 times 0, is that greater than 9? Or equal to 9? Yeah, no, it's not. So this is false. So doggone, I still can't shade that side, so I would pick side B. So side B would end up being the piece that's shaded in here. Okay, making sense? Okay, that's good. Okay, what if you just had one of these little specials that we've had? We've had our y is less than a negative 2. So that's a special one. What kind of graph is that going to give me? So if I looked at that thing, what would its shape be, or what would its graph be? So what do we know about y equals? And it's just a number. What kind of lines are those? They're horizontal. Yeah, horizontal flat things, right? So this is a flat thing at negative 2, right? So if I graph it, I'm going to be at a negative 2. And it's flat. And what did we say? Is it dashed or solid? Dashed. Okay. But what if Hawk said I need some points? What kind of points would we get? Got a whole gob of them in here. So I can have 0, negative 2. As long as y is 2, or negative 2, x can be whatever I want it to be. So I could put a 4, I could put a 3, I could put a 1, I could put a whatever I want to put in there, okay? And so now I need to find out what side gets shaded. Do I shade side A, or do I shade side B? So what would you guys shade? Side A or side B? 0, 0, but I can only plug in y. Is 0 less than a negative 2? Nope. So that means I would need to shade below the line. So that becomes my side that's shaded. Okay, you getting it? You got the idea? Okay. And then the other special was when you had x is greater than or equal to 5. So if I do this one, is my line solid or dashed? Solid, yep. And so then if I graph it, and we'll go into your Hawks exercise so you get an idea and see how they're doing them in there. This tells me it's what kind of line? Vertical at where? At 5. So 1, 2, 3, 4, 5. Vertical line, we said it was solid. And so I got a solid line. Do I shade this side or do I shade that side? So is it side A I shade or side B? I keep getting falses all the time with these. It's because 0 goes in for x. 0 is not greater than 5. So I will want to shade this side. So that's what gets shaded there. Okay, questions with this stuff? In intermediate, we put them on top of each other. So we might take this graph and stick them on top of each other. And so when you do that, 5 out 5, 1, 2, 3, 4, 5. Just so you get a chance to see what happens with that part, is this purple, it shaded this part over here. When I shaded my second line, it shaded out here. So my answer is where I have pink and purple together. So in intermediate algebra, we found that it was that side that was shaded. Okay, so we had double shadings in there. So this is used. It's not like we're going to do it in here and never ever see it again. So you're going to see it in my intermediate algebra class next semester. So that's where that happens to be. Okay, so that's the piece that fits in there. All right, questions with this part? So now the shortcut. Want the shortcut? You guys always like the shortcut. And if you can't get into using the shortcut, just use that test point in there. So the shortcut is if it is greater than or equal to, shade above the line. Okay, so shade above the line. So what that would mean is if you had a negative slope, we would shade above the line, okay? If you have a positive slope, we would shade above the line, okay? If you have a horizontal line, you would shade above the line. If you had a vertical line, you would shade above the line. So that's kind of the shortcut of doing our shading. So I didn't use test points with that at all. So we shade above the lines if we have greater thans. So where do you think you shade if you have less thans? Under the line or below the line. So if I have a less than or equal to, we're going to shade below the line. So again, if I have my negative slope, I would shade down here. If I had a positive slope, I would shade below the line. If I have a horizontal line, I would shade below the line. Okay? And then finally, if you have a vertical, you shade the side of the line. Okay? But if you can't remember those, test points work wonders. They're the best plan for these, and to stick a test point in there so that you know what you happen to have happening in those equations. So let's shift gears here and let's pull up the assignment that is for 4.6 in Hawks, so we can get an idea of what types of stuff they're going to ask you within this assignment. So let's just get to practice. So in practice, they show you all of the different pieces that we just went through and did in there. They give us an equation, and our equation happens to be this piece up here. So first off, we got to pick a side of a line that gets shaded. So what side would we pick? Would we say it's dashed or solid? Dashed, the easiest piece of the question altogether to answer. Then over on your paper, you're going to want to, let me get this written out here, my notes in line. You're going to write that down on your paper. So we're going to put 3y minus 5x is less than, or is greater than 15. And let me go back to my ladybug here. And we're going to solve for y. Because if I solve for y, I can get those points a whole lot easier than trying to plug in points. So I'm going to add 5x to both sides. And I get 3y is greater than 5x plus 15. Divide everybody by 3. And so I find out y is greater than 5/3 x plus 5. We all agree? Good there? Okay. So my intercept is 5. So 0, 5. My slope was 5/3. So now if I go back to my question that I have, I can put a point in here. And that point I can put in there is 0, 5, because that's my intercept. Okay, we good there? And notice how it plopped that point right in here on your graph? You see that? So now I can take that slope, and the slope said rise 5, so I want to go up 5, 1, 2, 3, 4, 5, and over 3, 1, 2, 3. That will be a location of a point. So where is that? Where's that point at? It's at over 3 and up 10. So I'm going to type in over here 3, 10. And notice how it just automatically pops my line in. You see that? Once I put the point in, my line's there. And notice how it's also put in here, side B and side A. So now I got to bring this up a little bit. So what side do I shade? So if I follow my rules, I'm going to shade where? Above the line, so I'm going to shade where B is at. Okay? If you want to double check and make sure it's true, use your test point of 0, 0. 3 times 0 is 0, minus 5 times 0 is 0. So I have 0 is greater than 15, which is false, so I don't want to shade where that's at, so I shaded side B. And then you submit your answer. So all of it is worked out on one separate page, okay? So you get to see those pieces in place, okay? So again, with this one, same process. So dashed or solid? Dashed. Whoops, hold on, click dashed. Work this out on my paper. So take 4x plus 6y is less than a negative 36. Go to my paper, maybe, and we're going to work it out over here so we get y by itself. So I'm going to minus 4x. Negative 4x minus 36, divide by 6. And I find y is less than, this reduces to a negative 2/3 x. 6 into negative 36 is a negative 6. So I have a point, 0, negative 6. We good with that? Question? Or you just, okay. So now I can go back to my Hawk stuff and plug in 0, 6, negative 6. Put the right 6 in there. And it put my point in, so now I can use my slope, go down 2 and over 3 and find that location. So where is that point at? So it's at 3 comma negative 8. 3 negative 8. So basically, I've just used my graph to help me out with this. So where do I shade? Below the line, so B again. And check it, 0 in there. I get 0 and plus 0 is 0. 0 is not less than a negative 36, so I shaded B, so I shaded it correctly. Okay, what do you think? Getting the idea? Hopefully. So let's skip this one because it's the same process, basically. And let's see what other kinds of things they throw in here at us. This one, be careful because it's backwards. The y is on the right and the x is on the left. When you move 16 over and divide by 4, let's stick this one over here on paper so I can show you. 2x is greater than or equal to 4x, or 4y, I should say, plus 16. When you do this one, you are going to get y by itself, so I'm going to minus 16. Divide everybody by 4. So I get 1/2 x minus 4 is greater than or equal to y. But don't leave it like that. Remember in chapter 3, we had these inequalities and we reversed them. So y, keep the point towards y. Then you can see that it's now in slope-intercept form where you can pick out your pieces. Okay, so you might want to reverse those. So negative 4 is my intercept, my slope is 1/2, and then you can go through and do the problem the same way as we've been doing them. So just be careful with what they give you for different types in there. Same thing with this one, but what do I have to do differently? This is 8x is greater than or equal to a negative 4y plus 32. So if I go back and look at this one, what has to happen to it? I still got to solve for y if I'm going to graph it. So I'm going to minus 32. What was that? Yep. Or we could just move the y over, move the x over, and we're good. Okay. If I do it this way, and I divide by negative 4, back stuff from chapter 3, we had to flip our inequality because I divided by negative 4. Okay. So this is really 8 divided by negative 4 is a negative 2x. Negative 32 divided by negative 4 is a plus 8. The inequality needs to switch, and I get y. Okay, so if you moved the 32 over, that's what happens. But if you move the 4y over and get 4y plus 8y, or 8x is greater than or equal to 32, notice when you move the x over, we're going to keep that y is going to be positive. I don't have to flip that. But notice it still comes out the same because I really have to have a greater than in there. So be extra careful with the ones that have negatives with the y's when you're doing those problems. Do I need to finish this one? You want me to finish it? Are you okay? We'll finish it? Okay. So if we finish it, my intercept was 8. So my line is solid. My intercept is 0, 8. I had a slope of negative 2 over 1, so I go down 2 and over 1. So I want that point, so it's 1, 6. Okay. Then I need to determine what side gets shaded. So again, it is my sign flips, so I have to be real careful when I'm shading with these. My best bet is to use my test point. 8 times 0 is 0. Is 0 greater than or equal to a positive 32? 0 greater than 32? Nope. So I'm going to pick side B. And so then when I submit it, everything comes out correct. So if you're unsure of what sign you have, check, do the extra check in there, because that's going to tell you whether you did it right or not. Okay? But I think you can handle these. What do you think? Okay, let's keep going and see what else we put in here. Because we're only on problem 7. This one, I got the 5 over and then just change my points. Notice it's a little different with this one because this one says slope and it says the intercept. So I guess we'll work through this one. Is the line dashed or solid? The line is solid. Come on. There we go. And I need to work that problem out. So if I take it over here on my paper, 5x is greater than or equal to y plus 5. Get to my paper. And again, you can move the 5 or the y, whichever. So I'm going to move 5 over. And I get 5x minus 5 is greater than or equal to y. Reverse it. Point stays towards y. My intercept is 0, negative 5. We're good there? What's my slope? Slope is 5. Or 5 over 1. So now if we go back over here, we can end up putting in what our slope is. Our slope is 5. Our intercept is 0, negative 5. Very important you get your negative in there. It's put the line in for me. Now I need to decide what side's shaded. 0, 0 is here, not part of my line. So is 0 greater than or equal to 5? Every one of these has been false. So that one's false too. So we shade B. Again, when we reversed it, y was less than that value. So that's why we're shading below the line with it. Okay? So again, same kind of problems. I just give you a whole bunch of different ones that are still in here. But they're similar. This one's got a negative y, so you got to divide by a negative, so flip your inequality. We good with that? You want to do this one? Should we do that one? Are we good? Okay. I'm getting thumbs up out there, so we're going to skip it. So skip this one. And same thing here. You got to get your y's together. This one's a little different. So is the line solid or dashed? Solid? Okay. Write it down on paper. So 3y plus 2x is greater than or equal to 3y plus 4. Go over to my paper and work this one out. When I get my y's together and I minus 3y, they disappear. Dividing by 2, I find out that x is greater than or equal to 2. So what kind of line is this one? It's a up and down, vertical, yeah. Yes, it's vertical. It's a vertical at 2. So when I go back in here to my Hawks thing, my points that I pick, as long as x is 2, we're good to put anything we want in for y. So I'm just going to put 1, and we'll put 5. And we're good, okay? So I don't have to be real creative on what points I pick. Side that's shaded, 0, 0. So 0 is greater than or equal to 4. False once more. So my side is B. Be nice if we got one true. Everything seems to be false. Okay, so sometimes they all disappear. This one you got to distribute and then solve for y. So it's just looking at a little bit different setups with those. Same thing here. Being real careful with negatives on your y's. This one, the x's are going to disappear again. And that one, the y's disappear. And this one is a little bit different because it's got 30 in the denominator. Line solid or dashed? Dashed. No equals. That's, again, the easiest piece to pick out. So then let's do this one over here on paper. Just because it's a little bit different than some of the others. And so I'd have to multiply every side by 30. These will cancel. 30 times 1 is 30. Move my 5x over. I get 3y is greater than negative 5x plus 30. Divide everybody by 3. So y is greater than negative 5/3 x plus 10. So now I think I might have everything I need to do the graphing now. So paper, you need paper along with these as you do those. So 2 points, 0, 10. Give me 0, 10? Yep. Slope, down 5. 1, 2, 3, 4, 5, and over 3. So again, locate that point. So it's going to be at 3, 5. And then I got to decide on my shaded region. Since it is a y is greater than, I am going to shade above the line. So I'm going to pick B. So we will submit our answer and see what happens, and we're good. Okay. Then back to the same kind of solving as we've been doing. Okay. You guys good, you think? And it's going to tell me I didn't do very well because I only answered 6 of the questions. But I think you got it, right? What do you think? Okay. All right. As long as we got that down, we're good to go. All right. Take a break, and we will get back here and take a look at your graphing calculators in connection with graphing So this sheet that I gave you earlier has the directions for using your graphing calculator. It's important to learn this, but actually when we graph using slope intercepts, it's actually easier than doing your graphing calculator stuff. But we're going to still talk about it so you get an idea of what types of things to do with that. At the very top in your graphing calculator, you've got a whole set of keys up here. These keys do all of your graphing. So they're the ones that we're going to use to put these lines on, and we're going to be the ones that we're going to use for the different pieces. If you hit your y equals key, which is right here, your y equals key will have, maybe it has stuff in it, maybe it doesn't. If you've used it in a different class or used it in high school or used it who knows where, or you borrowed it from somebody, that person might have worked with lines and stuff in there. So you have different things in here. So to clear it, all you do is go to your clear button, which is down here, and hit clear, and it'll wipe out whatever you have. Up above, you have these things that are called plots. Plot 1, plot 2, plot 3. Those are used if you're graphing random selected points. We don't use them here. They use them in statistics a lot because you get an idea of where those happen to work at in there. So that's what that key does. Notice they're all y equals, no x equals. So if you run across something you're going to graph that's an x equals 7, you have to just remember that is a vertical line at 7, and I think you guys got that because we were talking about that a little bit earlier, and I think every one of you was saying, I know that's a vertical line that's running there, and I can't put those on my graphing calculator. Unfortunately, they don't work. So the other piece is that everything has to be solved for y. When we did this last section, we solved everything for y. We went and we moved things around and we got y all by itself. And the reason is if you're going to use your graphing calculator, it has to be solved for y in there. Over here is a graph key, and if you hit that key, it's going to give you the grid that we've been graphing on. So you shouldn't have anything in there if you cleared everything out. Okay, so you should just have your grid that's there. With that one. The Windows key, which is right here, the Windows key is how that window is set up, meaning that it's the minimum on your x-axis is 10. So that means when you had this graph piece back, it was over here out at 10. The max is out at 10 on x. And then the scale, when we go back to it, I'll show you that in a second. The scale is in increments of 1, meaning that every square or every piece in there is equal to 1, representing just like we have in our own. Then the y minimum and the y maximum is -10 and 10, and the scale is 1. And this other piece at the bottom, we don't do much with it. If you ever see an over arrow next to that, that means that there's more stuff in your calculator. And again, we don't change this part at the bottom at all. And so that's what your window does. But we can change windows and make those all different as well. Then you get to your zoom key. The zoom key is just like a zoom on your camera. It zooms in, zooms out, and it makes your graph bigger or makes your graph smaller, so it's out farther and you see more points on it. So it's just kind of doing that piece. And then above the graph key, there's a table key. And if you use your second, because it's printed on the base of your calculator, and hit that, you get a table. And in here, your table is going to show you your x values and your y values once we put something in there that we want to work with. And so we want to take a look at that piece in there. So let's play around on the back side of this page, and let's see if we can put a graph in here and see what we can gain from this information that we have. So to solve, you go to your y equals. Everybody at y equals? And we're going to put this first one in here. The piece I don't have to put in is the y equals because that's already there. So I'm going to put 3. Your x is either right next to your alpha button, and you just hit that key and it puts an x, or you can go alpha, and if you use your alpha button, I always have to locate this thing because I never use it this way. It's, where is it at? Yeah, it's right there above your store key. you see X in there. So X is right there if you want to use that, but you got to go alpha to use it. We're here, I'm going to just hit one key. So we put in a 3, we put in our X, minus 5. Be careful, make sure you put a minus 5, not a negative key down here, 5. Then, if I go and hit my graph key, it will show my graph of my line. Okay, so that's kind of what we've been doing by hand, is we've been graphing this stuff. And if you notice, the slope on here is 3. The intercept is a -5. So if you look at your graph, it's crossing at 0, -5. If I do my rise over my run, I run up 3 and over 1, you're going to find that it's going to show it on that graph as well. So it's all right there. And so you get to see what it looks like. Back in 4.1, we were having to find points. 4.1 said, plot some points. Give us an idea what this graph looks like. The neat thing about your calculator is we can now go second, hit your table, and we've got a whole gob of points in here. Notice it gives me all kinds of different values in there. I can keep going up and down on my negatives and my positives and coming up with different things. So you might be at a different location than I am. So every X is associated with a Y, and so I have points. So in 4.1, if I had my calculator, I could have solved for Y, plugged it into my calculator, hit my table, and boom, there's my points. But again, I think it's understanding what your graph and what your stuff is doing that makes a big difference with that. So you want to make sure that you end up doing that and finding out what your graph looks like. We good on that part? So what happens with number 2? Let's go and put it in Y2. So if you down arrow to your next Y2, we're going to put in -2. Now I have to use the negative sign here because it's not a subtracted 2, it's a -2x plus 6. And if I hit graph, the first line's there, and in comes my second line. And we found out that the first line was a positive slope because my slope was a +3. This one is a negative slope because my slope is a -2. So it slants it in the opposite direction in there. If you wanted points on it, second to table. And you have to look at the Y2 column that's associated with your X. So at a -2, I'm at 10. At a -1, I'm at 8. At 0, I'm at 6, which I should be because that's my Y-intercept, and so forth within that. So you can get your points out of there. So you get ideas on what type of stuff happens to be in that. Okay, make sense? Hopefully, okay, and finding your pieces. So if you did our last section, 4.6, we can do those on here too. If you go back to your Y equals, and we're going to clear out the second one just so that we don't have to have it there. So I'm going to hit clear. Go back up to your top one, and if you over arrow, back arrow, to right in front of your Y1, can you get there? Back arrow right in front of Y1. If we're right there at that point, I can hit enter, and if I hit enter, notice it changes. That's kind of just a solid regular line. If I hit enter, it gives me a deeper, darker line. If I hit enter one more time, it's shading above the line. Notice how it's got that shading part above it. So if I had a greater than, so if I had changed this equation that I had over here to y is greater than or equal to 3x minus 5, I would select the greater than. If it were y less than 3x minus 5, I hit enter one more time and I get below the line. Okay, so it's shaded below the line. That's what I would need if I have a less than. So greater than's above the line, less than's below the line. And so now if I hit enter, or not hit enter, I've got it where I want it. So hit the back space or the back arrow and get back to your graph. And now if I hit graph, the graph button, it's going to take that line and it's going to shade where it's supposed to be shaded, just like we did in 4.6. So it gives you an extra check to see if you did your equations correctly that you have in 4.6. So you can do shading with this stuff as well. So questions with those things and putting stuff in your graphing calculator. It always has to be solved for y equals first. You cannot put anything in if it's not solved for y equals. So let's look at some over here in numbers 5 and 6 that are not solved for y. So let's see what happens to those. So if I took number 5 and I solved it for y, what would I have to do? Well, I have to move 2x over. So that's going to give me a negative 3y is equal to a negative 2x plus 6. Divide by negative 3. And I find out that y is equal to negative 2 divided by negative 3 makes it positive. And 6 divided by 3 makes it a 2. So now if I want to put this on my calculator, I go to y equals, clear out what I had in the first one, and I'm going to put 2/3. Now how do I put 2/3 in there? Well, that's a good question because 2/3 is a fraction. So all you need to do is go 2 divided by 3 and then hit your x after it. And your calculator is going to recognize it as the fraction in there and do it first, plus 2, and then hit graph, and we get an idea of what our graph looks like. So then over here, I would simply insert and put what my graph happened to look like within that one. Okay, what do you think? Not so bad on working with these. The next one, same process, dividing by 10 in that case when we get all done. And so then you would graph it and see what it looks like. It'll come out as a fraction too. So I get 10y is equal to a negative 5x plus 20. Divide by 10. And I find y is equal to negative 5 over 10 reduces to a negative 1 over 2. 20 divided by 10 comes out to be 2. So when I go to my y equals, we'll go down and put it in the next slot. Negative 1 divided by 2, x plus 2. And if I hit graph, first line's there, second one comes in and does this. So I'd draw it in and what it would slightly look like. Okay, are we good or not good? Question? Yeah, question? Shouldn't it be a positive 5? A number 5?
Yeah, the 2, would that be a positive 2? Would that be 2 equal 5?
No, because it's a positive 2 here. So I really needed to add a negative 2 to both sides. So that would be a negative 2x. We good now? Yeah, I'm doggone negatives. The bad things about those. I was like, why in the world they had to design those, negatives. Yeah, but they got to be part of math. Unfortunately, they're part of what we have. So you good? Okay. So then again, if we had changed this and we said it was 5x plus 10y is less than or equal to 20, then I would have that symbol in between here. So when I did my y equals, I would have to go over here and I have a less than. So I want to do my enter, that's a greater, that's less. Get it back off of it, hit my graph, first line coming in, second line coming in shaded, okay? This would have been the first one that came out true if I put zeros in it. We haven't had a true one all day, but that one would have worked out to be true. Okay, so questions with this stuff? Okay, then if you flip back, it gives you some other things over here that lets you change your windows. So if you change your windows, so if I go back to Windows, and it says change the minimum to a negative 20, change the max to 40, change the scale to 5, and you just go through and type these, negative 10 for the minimum for y, max is 60, the scale is going to be 10. And if we take a look at our graph, based on this, our graph looks kind of funky. See how it changed? Our graph ended up not looking exactly the same because I've moved everything around in there. So if you do that and you change a window to get it back, above zoom, you hit your zoom button and go down to number 6. And number 6 will turn your graph back to what it normally was. So if you ever are graphing at home and your graph on your graph calculator does not look anything like what you graphed without it, that can sometimes be the problem. Is you hit zoom, go to standard number 6, and it will standardize and get your graph looking right again. Okay, because sometimes windows get bumped or played with, or a number gets put in there and it comes out different. One last thing I want to show you is above the Windows button, there's called Table Set. If you go second and hit that button, it tells me where my table starts at. So if I went to table, I'm starting at a -2. But if I wanted to change that, and let's say somebody wanted to know what it was at 40, I could put 40 in there, then go and hit my table, and it will show me what the answers are for my 2 lines at 40. So you can change that and come up with whatever your values would be in there. So that lets you change that stuff around. How many of you worked with graphing calculators before and did graphing? So few of you have. Okay, rusty, but it's there. So did it come back? Probably did. But again, that's the key on those, and it helps you out with that stuff. So, okay. So that was basically all the stuff that happens to be on this sheet, and so it just kind of went over. Yes?
Are we going to do graph like this in
No. No. In intermediate algebra, we use it to do the graphing, some of the graphing within there. So learning where your keys are, but again, like I said before, actually slope intercept on linear lines, on straight lines, is easier to do than this. Okay? And the kind of graphing we're going to do in intermediate might be the double graphing, the double shading, but our graphs change in there. We get parabolas, which are U-shaped things, and we also get radicals, and the radical ones come through and they look like this, and so your calculator will change whatever you put in your y equals. So it's a lot of more y equals stuff and figuring out what goes in there. Yep. Okay. That help you? Make sense, I hope? Again, it's just kind of a brief introduction. We used to do a lot more when we had our algebra labs, and we could play around more with the calculator. And here it makes it kind of tough to get enough time and get all the stuff we need to do. Okay, so your homework this time around is 4-6, and also do your practice test. There's a practice test that's made for you, like the chapter 3 one was made for you. Just go to tests, click on that one that is the practice test for 3, or for 4, I should say, and that will give you your practice test. It gets recorded in my grades, but it doesn't get recorded in your grades per se, your grades, until I enter it as your 5 extra credit points. And if you've got all of chapter 4 done, you get your 4 extra credit points. So for some of you who haven't did all your homework and are kind of starting to slip a little, it's a good time to start fixing that and get all the 4 done so you get a really good, solid, high grade on chapter 4. Okay? Pardon? Monday. Yeah, this coming Monday.
review the section and practice.
Yep, and don't forget to do your review too, so that's in there as well. Okay, so. Give you some time to maybe work on your 4.6, because it's probably will go pretty quick once you get going on it.